Group 17, and this is our last lab, E5, the system design. So this is our circuit. This is the FRDM board inbuilt with the Nokia 6610 screen, and this is the piezo electric buzzer. So I'm talking about the RTC. So RTC actually, so it's a normal clock, has a crystal that has a frequency of 32 kilohertz. Hence we have masked up to that frequency to match our clock. So talking about the RTC, we actually first initialize the RTC, and we have unlocked some of the registers. So basically, if you see, the first register we unlocked is the TSK, that's called the time seconds register. So we unlocked this to allow the increment of every second. And then we unlocked the LK, it's called the lock register, and we unlock this register, and actually there are two registers that we unlocked in these registers. Those are the status register and control registers. There are a lot more registers under this register which we haven't unlocked because we are not using that. So actually this is enabled by the VB80POR or the software reset. And then we unlock the register called the SR. It's called the status register. So this is actually unlocked to increase the time free scaler and the time second registers. And lastly, we have unlocked the register called the IER, interrupt enable register. So this interrupt enable register is actually unlocked so then it counts every interact. So this function is actually called in the main, and now this is the source file of that. So as you can see, every second, meaning seconds, there's an increment here, and then after every 60 seconds, it's the minute. So after every 60 seconds it goes to the minute. Now after every 60 minutes, and then it moves to an hour. So after every 24 hours it moves to a day. So this part of the program shows how we handle with the months and the year. So as you can see on the top of the 1, 3, 5, 7, 8 and 10, 12, these days that has the days of 31. So if one of those days, then it will have days of 31, and if not, then it will have an increment of 1. And then we have a special scenario for February which has a days of 28. So if the days are less than 28, and it shows it has a month of 2, which is February. And this function shows coding for the months that has days of 30. And as we know that in a year it consists of 12 months, and if the month is equal to 13, which is another year, and there you can see just goes the increment of another year.
So I'm going to talk about music generation part. For that we are using this play note function. We are going to pass down the frequency and beat values to this function, and that frequency will be stored in this note, and tempo will be taken by multiplying the beat value from 32. So we are checking if the frequency is 0 or not. If it's 0, nothing's gonna play because the frequency is 0. Else, according to its prescale values, these channels will be activated, these FTM channels. So FTM 0 will have a prescale value of 1, and FTM 1 will have a prescale value of 3. When tempo is greater than 0, if FTM channels got activated, then it will trigger the interrupt handlers. So we'll check out the interrupt handler functions in the main. So first, this is for the FTM 0. With the when this triggering will happen at half period of the node. That will happen in the FTM node function. So at FTM 1, this handler, what will do is it will decrease the tempo with every cycle, and till it gets 0, it will keep doing the decrement. So from that we are getting the duration for the note. That's it. Okay, now let's see how this function creates the melody from the header using the header file. First, we clear the LCD and we put the color red. Then we put a message saying wake up when the alarm triggers. So as you can see, to create notes and to get the whole melody, we are passing down these frequencies and how many beats for this note to this play note function. So this C6, E6, all these frequencies are stored in the header file, and that was given. And after that we are checking if the alarm was triggered, if the alarm trigger is equal to 0 or not. If it's 0, then basically means that we are checking if the center switch is pressed and we have to stop the alarm or not. So that's in the if statement.
Okay, we are in the lab 5. Now I'm actually going to explain you the interface of it and the operations. So first you can see this is how we made our interface. This is the analog clock and this is the digital clock, and then you have the date and also you have the alarm. So as you can see, these are the defined ones for like our interface, our clock color and the date color, select color, everything, like whatever there's in the display and the interface are predefined in here, but later we actually change these values. So you can see in our, this is where I generate the setting for the interface of the analog clock. So as you can see, the draw circle function is used and the 12, 6, 3, 9, the put string function is used to like put it into the display. These are actually in the header file. So these actually like have the predefined functions, and this is for the display like of the digital clock, and also the our date one digital clock, and also this is for the alarm. So these use the same background color, which I set it to green. And as you can see again from here, so if I press the middle one, which is the center switch, it will actually, oh wait, this is the clock menu, which is the sub menu of our display one. So in here, whenever the switch is like either pressed, we actually go to the sub menu. So in here, like it actually shows you like whether the settings and set time, set date, set alarm and exit. These are the 4 settings we have. And in these like case1, case2 are therefore because whenever like the center switch is pressed and whenever like we are selecting, these things will appear. It will highlight the one we want. So as you can see in the clock, if I press the center one, it will go to the settings menu, which is this is the sub menu. So set time is initially highlighted, but if I press it down, it will go to set date and set alarm and also exit button. And to select one, I just have to press the middle one. So if I manage to set time, first I go to set menu and then I set time by here. First it was the hour ones and this one is the minute one. So it's already running at 2, but if I want to set it to 4, so I increase up to 4 and for 5 minutes, and this I'll give it like 5. So okay, so this one should give you 5 hours and 5 minutes, which is 5 past 5. So if I press the enter one and if I exit, you can actually see it. The hour hand is in the 5 and the minute hand is also is in the 5. So in the digital clock it runs as 5:5. Now it's 5:6 because the minute the second one always going. And as you can see, if I want to set the date, I go here, I will give it 25, and if I want to make it 12, now it should be in December. Sorry, see, and now we are, it updates to 12th 25. Now we'll check the setting alarm function. So in here the setting alarm, as you can see, it's initially the default value is 0, but I will, if I give it to 4 and yeah, this is will be 2, so 2:10, sorry, 2:09. So alarm is at 2:09, but our time is 5, so I'll give the time to 5, sorry, to 2, 2, 7, 2, 8. And so yeah, now we had to wait for one few seconds. So when it become 2:09, the alarm should ring. As you can see, the each second the analog is the second hand is moving, and also it's updated in here as well in the digital clock. So in 10 seconds it will ring the buzzer according to the melody we created. Yes. So yeah, it's with the red background, and wake up message is also clearly shown for the user to wake up. And if I press the center button again, it will clear the alarm. As you can see, here's the date one. So if the date should only go to up to 31, and the month is already 12/2017. So if I increase it up to 31 and beyond, the month should be 1, and this one, the year also should be changed to 2018. So let's see if it's happening. And 30, 31, and you can see it's the 1st of 2018 and January. So as you can see, I'm again going to explain you the operations properly. Now these are the default values which I have given. So if I go to the sub menu, and if I want to set time, as you can see, this is should only go until 59. So you can see that after 59, the minute one will turn to 0, because you can actually go until 59 when it's come to minutes, and the second one works all the time. So yeah, after 59 it's 0. So in here is the hour one, so it could go until 23. Yeah, up to 23, it's like that. So if I want to set time, I just give a random value 22, and if I wanted to make it let's say 45, and I set it, and when I exit, as you can see, it gives me in the analog also shown, and also digital is shown correctly. And for the date, as you can see, the first one is 20. This only should go until 30. So since it's the 11th, it should go until 30, and after that it shows 1. But in December 12, it should go on. Okay, let's say the decrement, it should go until 31. So yeah, 31, and as you can see, when I go for 28, the February is only 28, and if I, this is the 2018 12, and sorry, if I okay 12, and if I go for like I'll be answering the questions which is asked in the blackboard. So first one is, what is the controller doing most of the time? So actually basically it's a clock, so the clock actually has to update each and every second. In here we use a real-time clock. This is actually connected to an external clock 32 kilohertz crystal, and the system is not interfering the RTC clock. When an interrupt happens, it actually takes to a unique code zipper, which is actually called the request handler, as you can see in here. So this is our interrupt handler. So this is called RTSecond's IRQ handler, which is actually the interrupt request handler. So this actually points to a clockwork function which was explained earlier. So this clockwork function will actually update each second, minutes, hours, months, days, months, years, everything will be updated, and even if we click something, a switch or whatsoever, it will actually do according to this clockwork function. Yeah. And our second question is, what is the system frequency of your system and how did you get it? System frequency, the FDRM actually has 20 megahertz, but when we include the clock.h, it goes to 48 megahertz. The system frequency only changed for the FTM module, but the other than that, the 14 megahertz is for everything else is 48 megahertz. And the third one is, how does the system frequency affects to FTM module? So in our music music function, okay, in here you can actually see we are using two FTMs, which is the 0 and the first one. So actually in here the FTM 0 is prescale 1. So if it's prescale 1, you actually divide the system frequency by 2 to the power prescale, which is 2 to the power 1. So the value is 24 megahertz because 48 megahertz is divided by 2. And for FTM1, we are using the prescale 3. So it actually means the system frequency is divided by 2 to the power 3, which is 8. So it gives 6 megahertz. And for our last question, how does the system frequency affects your RTC module? RTC is controlled by an external clock, as we said earlier. So it is actually not affected by the system frequency. Because if it actually did affect the system by the system frequency, when we actually have a function inside the RTC, the calculations which will be done by using the system frequency will be wrong. So everything like the seconds and everything will not be as we expected. Thank you.